Hello, this is going to be the demo for my final project for the embedded microcontrollers class. So what I'm going to do real quick is do a quick rundown of my system and how everything is configured, and what the output and nominal operation looks like. So to get things started, here's the board. I apologize for the rat's nest. It's kind of hard to get all of these wires organized. There's a lot of stuff going on. So basically what I have here is I have the STM32 board, which is connected to the LCD screen that we had used in Lab 11, as well as the joystick that we used back in, I want to say Lab 7, and then the RC low-pass filter circuit from Lab 8 with a PWM. All of the GPIO configurations are detailed in the report, so you can refer to that for exactly how everything is hooked up. But basically, to give a gist of it, we have the joystick is configured to ADC1's channel 1 and 0, and then it has this. We didn't use the switch button, the switch signal before, but I'm using that in this lab, in this project, and that's configured to a GPIO as an interrupt input. So that's set up to ADC1. We have SPI1 connected to the LCD, which also has the data and command signals and all of that stuff. And then timer 3 channel 1 is connected to the PWM that's going into this RC filter circuit that we have here. And then the output of that RC filter is going into my ALM 2000 module, which has Scopy running, so you can see that it's generating the output here. Finally, we have the USB cable going into my computer from the debug port, and that gives us the user terminal, which I have open up on TeraTerm, and that's running at 115200 baud. So basically, the gist of it is that this joystick is used to control the this might be a little hard to demonstrate exactly, but moving this down moves the cursor on the menu. So if I were to, might be a little hard to see, but you can kind of make it out in the background. Moving the joystick up and down moves the cursor appropriately on the UART terminal. Basically what I'm doing here is just clearing the screen every time I witness a good ADC event, and then just go ahead and reprint the whole the command menu. And then obviously we have 3 different types of waves. We have the sine wave, triangle wave, and square wave, and then I offered 2 commands for increasing and decreasing the frequency. I wanted to give the user better resolution on the control for the frequency, but it turns out with the prescaler, the formula for the frequency into the PWM timer is clock frequency divided by prescaler plus 1. So every time you increase the prescaler by even a factor of 1, you're effectively like dividing the frequency clock down by a large factor. So I had the APB1 clock configured to 64 megahertz. So nominally the fastest we can go is 64 megahertz with a prescaler of 0, and then you need I've set it up so that the PWM has 255 pulses 255 pulses per period. So that comes out to like 64 megahertz divided by 256. And then with all the overhead with the software and stuff, the fastest frequencies I was seeing were something like 200 hertz or something. So in my mind, giving the user fine resolution over that didn't really make sense, because even changing the prescaler by a value of 2 or 3 causes the system to kind of hit its bottleneck as far as the frequency output goes. So instead of allowing the user to tune frequency to what they to manually tune their frequency. I've decided to just have an increased frequency and a decreased frequency where I adjust the prescaler for timer 3 channel 1, and that kind of reflects in the output of the PWM. And because basically what ended up happening was the desirable frequencies were not attainable with the PWM rates that we were seeing, and if the clock on the timer was a little faster, we might have been able to see better rates on the output. But that's just how it ended up working out. And I discovered this pretty late into the project, and it was a little too late to turn back. So I just rolled with what I had. Anyway, we can see here that we're outputting a sine wave on Scopy. So what happens is, depending on the type of the type of output that you're generating, I use lookup tables to basically print out a type of a GUI interface to demonstrate what type of output the user would be looking at. And I apologize for the crappy art. This actually ended up taking me much longer to implement than I would have liked. I thought the sine wave ended up looking okay, but it's not ideal. I chalk it up to the fact that the rotation, I wanted there to be a rotation that allowed me to treat this corner as 0, 0, but I wasn't able to find the correct configuration for that. So I just worked with what I had, and I generated this. So from here, it's a little hard to see because recording is difficult when you're also operating the menu. So if I switch over to triangle wave, we can see that the output has changed to a triangle wave. And I've also drawn a sort of triangle wave here. It's backwards because of the rotation, but I think it gets the point across. We're doing a triangle wave. And then obviously if I switch over to a square wave, we have a square wave on the output here, and then I draw a square wave on the LCD screen. So that's that as far as that goes. And then I also have controls for increasing and decreasing the frequency, like I mentioned. So if I increase the frequency, you can see the frequency does get faster. So, and then I can decrease the frequency as well, and it makes the signal slower. One thing you'll notice here is that the amplitude of the signal changes with the frequency. This is I'm chalking this up to the RC, the time constant on the RC low pass filter. I think nominally you would want to have a more robust RC circuit for the type of charging and discharging that needs to happen. I'm not particularly good with the analog type stuff that's required to figure out exactly how that goes. I tried a few different types of resistors, and I put resistors in series and stuff like that to try and get what looked best. And this RC circuit was giving me the best appropriate response. So that's kind of what I just stuck with. So we can see here that if I oh yeah, I forgot to mention, pressing down on the joystick and clicking it is what triggers the command change. So I clicked down on it while it was on triangle wave, and now it's generating a triangle wave. So I'll go ahead and decrease the frequency of this guy, and we can see that the frequency is decreasing. And then, like, obviously as we decrease the frequency, the signal becomes more and more rough. That's because of the time constant again. You can start seeing the capacitor charging and discharging. It looks much better if we keep it in higher frequency range. But again, as we increase the frequency, the filter makes it so that the amplitude doesn't look as nice. And then changing over to the sine wave, we can see it does the same thing. I'm decreasing the frequency and increasing it. And that's all being controlled from this. And then obviously the LCD circuit is, it's hard to get it to prop up.